grade 7. How are you? I hope all of you are well and keeping yourself protected and hydrated and safe during this weather of smog. Uh, we do have holidays this week, but that doesn't mean that we are not going to work at all. In fact, we are going to work with the same zeal and zest. And in maths today, we are going to go to another topic, a brand new topic, that is area and perimeter. Okay, so you are basically familiar with finding area and perimeter of simple shapes like square, rectangle, triangle. Today we are going to focus mainly on area and perimeter of a rectangle, but this time the difference is going to be that the shapes are going to be more advanced and the questions are going to be of a more complex nature. To understand the concept of finding area and perimeter of difficult shapes or complex shapes, we are going to first do some work from our book and take help from the worked examples given over there and try to understand them together, and then move on to doing the actual questions which are given in our exercise. So first of all, I want all of you to open your books on page 135. It's going to be page 135. All right, and we are going to look at worked example 2. And specifically at the two parts, that is especially part A, because this is exactly related to our topic, that is area and perimeter of rectangle. Okay, so this is our topic today. Now, before we read this question and try to understand what it asks of us, let us quickly remind ourselves of the formula of square of perimeter and area of a rectangle. Yes, we all know it very well. Perimeter is basically when we add the length of all the sides of a shape of a rectangle specifically, and area is when we multiply the length or the longer side of a triangle with its width or the shorter side of it. So basically, if I want us to revise this, it's going to be something like this. We have this rectangle. Okay, so we have got its longer side as L and its shorter side as breadth, or it can also be written as width or W. Okay, so area means length multiplied by breadth, or length multiplied by width, whatever you want to call it, it's fine. Okay, and perimeter means what? You are going to add all the sides. That means L plus B plus B, which can also simply be written as 2 into L plus 2 into L plus B. Okay, so this is our, as you can say, small recollection of area and perimeter of any shape. So coming back to page 135, worked example 2, part A. The question asks us, which is asked of us, is A part. A path 4 meter wide runs around the inside of a square park of side 80 meter. Find the area of the path. Okay, so it is something like this. Although this picture is drawn on page 135, but why not draw it here again for more clarity? The reason why we are drawing it here is it will help us understand the question more. Okay, so they say that a path 4 meter wide runs around the inside of a square park of its side 80 meter. Therefore, so it says that there is a park, a square park, whose sides are of 80-meter length. Okay, no problem. Let's see. A square park which has got sides which are 80 meters long. All right, 80 here, 80 here, and 80 here, and 80 here. Okay. So there is a path which is 4 meter wide which runs around the inside of it. Let's see. And it is 4 meter long on all four sides. So let's now change the color and try to draw another path inside. Now the length of this is 4 meter. Okay, this is also 4 meter. Now the question is that we have to find out what is the area of the path which has got the length 4 multiplied by 4. Okay, so let's get on to it. As this is part A, we are going to write it like so. Okay, so it's going to be, again I'm going to write it over here in such a manner that you can remember it. This is page this is page 135, worked example 2, part A. First of all, what we are going to find out is the simplest of things, that is the area of the original park, that is whose length is 80. Area of park is equal to 80 multiplied by 80 gives us 6400 meter square. Okay, now what we are going to do is we have to understand this, that the inner path has got the length, the same length on all four sides. So this is also 4 meter and this is also 4 meter. So this 4 meter plus this 4 meter gives us 8 meter. So the total length is 80 meter. 80 minus 8 will give us 72 meters. Do you understand me? I have added this 4 meter with this 4 meter, which gives us 8, and subtracted it from the original length, which is 80, and I have got 72 meters. So now this calculation, this 72 helps us find the area of the square without the path. Now I'm going to write it with red to specify it. This is the area of the original park, 6400 meter. Now area of park without the path. path is, remember, which is running around it with 4-meter length, is equal to 72 multiplied by 72 equals 5184 meter. Alright, so we have got two values over here. One is this and the other is this. So to find out the area of the 4-meter long path, we simply have to subtract 5184 from 6400. So the area of the path is equal to 6400 minus 5184 equals 1216 meter square, and this gives us the answer. So this is the answer of the worked example 2 part A given on page 135. Let us revise it. We were given a square park whose length and width were 80 meters, and there was a 4-meter wide path running around the inside of this square park. We needed to find the area of that path. So we simply did two-step things. First, we found out the area of the original park, that is 80 multiplied by 80, which gave us 6400. Then we found out what is the length of the path running on all sides. On all sides, the length is 4 meter. So 4 meter plus 4 meter gave us 8 meters. We subtracted that 8 from 80 and got 72. This helped us find the area of the park without the path. And by subtracting this area of the park without the path from the area of the original park, we found out the area of the path itself. Now it does seem a little too much repetition of path, but when you read it, when you see this video again, you will definitely understand that it's not as difficult as it seems. So this is the first worked example, or first example that we are going to do. The second example that we are going to do is on page 137. Page 137, worked example 3. Problem involving composite shapes. Composite shapes are those shapes which are not regular shapes. If you look at these shapes, there is a rectangle within a rectangle within a rectangle. So you can say, by looking at worked example 3 on page 137, you can easily say that there are 3 rectangles in this picture. Now you will say, Miss, why do you say that? It seems to me like there is a purple or a lilac fat capital L here, and inside it there is another white rectangle. So what do you mean by composite shape? So this is exactly what I mean. They are irregular shapes, but if you divide them properly into 2 shapes, they could turn into 3 triangles, or maybe 1 square and 2 triangles. How? We are going to find out just now. Okay, if we read this question, worked example 3, page 137. Find the area of shaded region in the following figure. So if you just look at it blankly, in the first glance, you see that there is an L-shaped sort of a picture, a fat capital L, whose color is lilac, and then there are some readings given around it. And yes, there is another small rectangle inside that lilac shape. Lilac means light purple. There is a small rectangle inside that lilac shape, which is white in color, and it is definitely a rectangle, and its sides are 5 meter and 3 meter. So this is the shape which is given to us, and we have to find the area of the shaded region. Okay, so we know that for area we have to multiply length with width, whether it is the area of a rectangle or a square. Of course, in square, all the sides are of the same length, so the formula of square is L square, that means L multiplied by L. So without further ado, just try to understand this shape by drawing it. Okay, so this is kind of shape that is given to us. I'm going to move it over here and pinch it smaller. This is it, then this, then this, okay, and then we have got a small thingy, small rectangle. Now over here, because I can't color it, so what I'm going to do is just write their values. This is 3m, this is 5m, okay, this is 20m, this is 9m, this thing is 7m, and this is 8m. Okay, these are the values given to us. So let me start by telling you from the onset that there can be more than one ways of solving this question. We are going to follow the solution which is given in the book, so that there is no ambiguity in your mind. But just remember that it can be done in different ways also. So what we are going to do is we have got to find the area of the shaded region. Now you have to understand, let me just shade it a little bit. This could be called the shaded region, okay? This you can just call this shaded. It will be differentiated from the small white rectangle whose length is 5 meter and whose width or breadth is 3 meter. Okay, so this is the shaded part. All right, that's it. Okay, so according to the book, first of all, let's write the formula of area of a triangle, area of a rectangle. Let me just pinch it even smaller and right over here. Okay, just let it go something like this. Yes, so area of rectangle is equal to length into breadth, or length into width. First of all, let's find the area of white rectangle. I'm sure you must have figured it out by now. 5 multiplied by 3 gives us 15 meter square. So this is one thing done. Okay, actually that can be called as 1, answer 1. Okay, now now we come to the interesting part. Because it is a composite shape, we are going to divide it into two parts to find its answer. If we think of, look at this part, 8 meter and 7 meter. 8 meter and 7 meter. If we just draw an imaginary line over here, this red line, you can safely call this shape a square, or we can call it A also, and it's square A. Area of square A is equal to, sorry, not square A, area of rectangle. It's not a square, it's a rectangle. Rectangle A is equal to length multiplied by breadth is equal to 8 multiplied by 7 is equal to 56 meter. Isn't it so? Good, yeah. So this is answer number 2, or part 2. Okay, now let's look at the other triangle. We are calling it rectangle B. Okay, so let's write. I'm going to pinch it smaller again. Area of rectangle B is equal to L into B equals, what's the length over here? 20 meters. Multiply by what's the breadth over here? 90 meters, which gives us 180 meter square. This is the third value. All right. So what we are going to do over here is, as final answer, because we need to find the area of the shaded part only, so we are first going to add, let me just change the color of my marker, add the area of shaded parts, that is A plus B. So rectangle A plus B are equal to 56 plus 180 equals to what? It's going to be a 180, 200, 330, sorry, 230 if I'm not mistaken. Let's just do it over here so as not to make any mistake. 56 plus 180 gives us 236. Okay, now to actually find out what's their area, we have to subtract the white rectangle from it. That will be 236 minus 15 this will give us the answer 221 meter square. That is our answer. So basically what we did was that first we found the area of the unshaded part of the white part whose length was 5 and whose width was 3. The answer was 15 meter square. That is our first answer. Then we divided the composite shape into two rectangles, rectangle A and rectangle B. We found the areas of both rectangles. Area of rectangle A was 8 multiplied by 7, which gave us 56 meters. And area of rectangle B was 20 multiplied by 9, which gave us 180 meters. Then we added the area of shaded part and then subtracted the area of the unshaded part of the white part from it and found the answer, that is 221 meters square. So this is how we find the area of composite shapes. I hope you understand this. I hope you get it. Now what I'm going to do is pack it up and give you some work which you'll be doing in your notebook. I will explain that written work separately, and you will then do it and show me the work, because it's going to be done on a Tuesday. I want you to do it by Tuesday evening. So what I'm going to do is write over here your classwork. Wait. I'm going to pinch it up. Yes, like so that you can see it, and then I'll give you your classwork. So your classwork is, you are going to open your book and page number 136 page, and you've got to do question number 4 in your notebooks. Let's do this and show me the picture of your answer. So that's your question. I hope you understood how to find out area of composite shapes by cutting them or dividing them into different rectangles. I hope you like it. If there is any question, you know where to find me, and I'll be very glad to help you out. Thank you very much. Allah Hafiz.